Okay, so today is day 15 of the notes. This is the end of chapter 4. So after this, we are just going to start reviewing and get you ready for your tests. So hopefully you don't have too many issues with this particular section since the test is right around the corner. Everyone know where they're at in the notes packet? All right, sounds good. So here's what the questions are going to look like today. And I'll give you a second to write this one down. It says solve, and then it will have a formula for you. So here it's S equals 2 times pi times r times h. And it says solve for h. So we want to isolate the h. We want to get everything away from the h. So the way I'm going to start this is I am just going to underline the one I'm solving for. I want to get everything away from that guy. What is everything else doing to that guy? Multiplying. How do you undo multiplying? So I am going to divide by 2, divide by pi, and divide by r. Well, if I divide the right side by 2 pi r, I have to divide the left side by 2 pi r.
Is S a part of the equation?
All right, so the 2's are gone, the pi is gone, the r is gone. I have just h. And I'm going to rewrite it with the h in the front. So h equals s over 2 pi r. So you solve these the same way you solve any equation. You use inverse operations to get that variable by itself. The only difference here is that we're not actually doing a bunch of math. It won't be like 8 divided by 2 when you divide both sides by 2. Okay, it's s divided by 2, which you just write as s divided by 2. Okay? What are your questions on this one? All right. Here's the next one. I'll give you a second to write this down. All right, so I am solving for y, so I am going to underline the y. Now, what do you guys think we should do to get the y by itself? Multiply by what? Yeah, if you flip everything else, you could multiply by d squared over x, right? So just, let me change colors. Like this fraction right here, multiply by the reciprocal. That's going to work. Now, would the r, where should I write the r? Yeah, you could sneak it up onto the top. Good. That's where I would put it. I think that looks the best. And then the only thing that's left over here is the y. I like to rewrite it with the y in the front. And we're good. Now, if you didn't notice that you could do that, the other way would be to multiply by d squared first and then divide both sides by x. Okay? So if you wanted to look at it more as two separate operations, like you undo dividing by d squared by multiplying by d squared, and then you undo multiplying by x by dividing by x, you should end up with the same thing, and that's fine, okay? There are a lot like that case in here where you could do it all at once, or you do it piece by piece and you end up in the same spot. So I am solving here for a. So a is being multiplied by m, and it also is being added to m. So what do I need to do? Do we undo addition and subtraction first, or do we undo multiplication and division first? Okay, let's pause. If I had like 3x plus 6 equals 9, what would you undo first?
6.
Yeah, we undo adding and subtracting first, okay? The same thing holds true here. So the one I need to attack first is the plus m. So I have x minus m equals m times a. Does everyone understand why we did that first? Yes. Okay, the reason we did that is think back to just a regular old equation with numbers. We always undo adding and subtracting before we undo multiplying and dividing. It's the order of operations in reverse when you're solving. That's not our actual question today, though. And I find myself, even after years and years of this, going back to that. Like, if these were real numbers, which one would I attack first? Okay? Because sometimes it is hard when there's all those variables. You don't really know where to start. Okay, now what? Still going after the A. Yes?
Would we now divide by m?
Now you divide by m, and you're going to divide the whole side by m. All right, and I go ahead and write it in a different order with the A in the front. What are your questions? Yes, ma'am.
So, if you subtract m. Oh, okay, never mind. Sorry, because I did like x minus 1, so I thought m would just cancel out, but I realized you do x divided by m as well.
So an alternate form of this, you'd have to divide the x and the m by m. So an alternate form that I don't require would be that. You can't just divide the m's, though. You got to also divide the x by m. So if you wanted to take it a step further, you'd be here. That's not necessary, though. All right, here's D. All right, it's kind of hard to do anything when the t is in our denominator. Let's think of what we can do. Yes?
Can you multiply by 1 over 3 minus u?
No. Okay, so you could. The question was, can we multiply by 1 over v minus u? You could, but that would give you 1 over t by itself, which is not the same as t by itself. So that's not wrong. It's not the easiest way, though. I'm going to show you the easiest way. Yes?
Would we add u?
Nope. Can't add u. Let's try to get t out of the denominator. By. Yep. Yep. Yeah, if you multiply by t, it feels weird because you're just moving the t around. But again, anything else would leave us with 1 over t. I don't want to know what 1 over t equals. I want to know what t equals. So we got to get t up out of the denominator. The best way to do that is to multiply by t. So now we have ta equals v minus u. All right, what should I do now? Divide by a. All right, see how now t is by itself? So at the time, it might feel like we're kind of going in circles with the t, but the whole point is to get it out of that denominator to a place where we can get it isolated. Okay?
Mm-hmm.
What are your questions? All right, here's E. Yeah, so I'm trying to get the x by itself, but again, you're kind of stuck. Maybe doing some things that don't seem super helpful right away, but it will get you to a point where you can isolate x. Right now we can't isolate x because it's stuck in a parentheses. So let's first get rid of the parentheses. So I have a times x plus a times b, and that equals c. Then what? Subtract ab. So I have ax equals c minus ab. Now you can divide by a. And we have x by itself. It equals c minus a times b all over a. Okay, solving for a is going to be different. Now, if I distribute the a, do you think that's going to be helpful?
No.
That's going to make a in two spots. Do you think it will be easier to isolate a if it's in two terms or in one term? One. So let's try to think of another way besides distributing. Because it's not stuck in the parentheses, so let's not. Is that what you were going to say? Yeah, remember, distributing is just multiplication. You're multiplying this whole thing by a. So the way we could do it would be to divide the whole thing by what's in parentheses. And you don't really need the parentheses because the long division symbol acts as a grouping symbol anyway. So if you want to put the parentheses, go for it. If you want to leave it like that, that's fine too. It's a fun one, solving for two different variables.
Is this what this whole section is going to be about?
All right, now we're going to practice solving for x. Same idea. The x this time is stuck in the parentheses. So as you're writing this one out, try to come up with a plan of attack. Yes.
Multiply by 1/3 m.
Multiply what by 1/3 m?
Distribute the 1/3 m.
Okay, so that's one way to do it. There's, again, a couple ways to start it. We could distribute the 1/3 m. So n equals 1/3 m times a plus 1/3 m times x. Yes. Okay. Now what? Subtract 1/3 MA. Very good. So this is going to be n minus 1/3 MA equals, those are gone. I am going to put the m up top with the 1. Is everyone okay with that? I think that makes this next step a little easier, because now what? Multiplied by the reciprocal, which is 3/m. Now, when you're multiplying over here, see how this is a binomial? Two terms? You actually have to distribute the 3/m. All right, so that gives us 3n/m minus 3ma/3m. Everybody see that? And then that equals 3. No, those are gone, right? That equals x. Now, I would definitely not leave it like this. We want the x in the front. We have 3n over m. What happens to the 3's? What happens to the m's? Yeah, so it's just going to be minus a. Now, just a quick side note, I'll show you a little something extra over here. If you wanted to think of it like this, you could get rid of the fraction first. You could multiply both sides by 3 over m. And then you just be left with what you started with in parentheses and then minus the a. See how that gives us the same thing? So there's a few different ways to do these. Typically when the variable's in the parentheses, we distribute. But honestly, something as messy as 1/3 m, I don't know if I would want to distribute. I might just get rid of it to begin with. But again, you got some choices about how you want to attack these. What are your questions? Okay. Yes.
Subtract v1.
Not yet. This is like a bodyguard problem.
Oh.
You can't get up top till you go through who? The 4. So how do we undo the big dividing by 4? Big multiply by 4. It's just regular size, but it feels funner that way. I'm going to write the 4 in front of the c, so 4c. All right, once again, we're still going after the x. So, yeah, just subtract the by. Questions? All right. Ideas? Yes?
Multiply by 2 on both sides.
Okay, get rid of the fraction. Sounds good. So 2a equals bh. Divide by h. Good. I'm going to rewrite it with the b in the front, so 2a over h. All right, what did we learn about today?
Transforming formulas.
Good. Transforming formulas. That sounds very important, doesn't it? All right, and we are done with chapter 4. Woo woo. All right, here comes your homework.